Hello everyone from Math 2200, Discrete Mathematics. It's Professor Wenson here again with a video on your Zybooks, section 10.3. This is the generalized product rule, right? You saw the product rule in section 10.1. This is just it's in the title. It's going more general than that product rule you saw. Right, so let's take a look. So let's start with their example. They start off here with, consider a race with 20 runners. There is a first place, a second place, and a third place trophy. An outcome of the race is defined to be who wins each of the three trophies. How many outcomes are possible? So it says here all 20 of the runners are eligible to win the first place trophy. Right? Once the first place runner is determined, then there are 19 possibilities left for the second place trophy, since no one can place both first and second. Once the top two runners are determined, then there are 18 possibilities for the third place trophy. So the number of possibilities for the outcome of the race is 20 times 19 times 18, or 6,840. Okay. So this is kind of like forming an ordered triple, first place, second place, third place, but you can't repeat values. I couldn't have John, John, John for all three. You'd have John, Joe, Jack, John, Joe, Sue. But you can't repeat values. You can't repeat people. You can't repeat elements. So it's very similar to that. That's why it's more general than the original product rule, because there was repetition allowed in these ordered triples. Here there's not. So this race example illustrates that a useful way to think about counting is to imagine selecting an element from the set to be counted. The selection process is carried out in a sequence of steps. In each step, one more decision is made about the item that will be selected. At the end of the process, the item to be selected is fully specified. So the generalized product rule says that in selecting an item from a set, if the number of choices at each step does not depend on previous choices made, then the number of items in the set is the product of the number of choices in each step. And they write that a little more, hopefully, clearly here. So consider a set S of sequences of k items. Suppose there are, n1 choices for the first item. And then for every possible choice of the first item, there are n2 choices for the second item. And for every possible choice for the first and second items, there are n3 choices for the third item, and so on until for every possible choice of the first k-1 items, there are n sub k choices for the kth item. Well, then the size of S, the number of possibilities, like in your running example up top with the trophies, would be just the product of those values, n1 times n2 times nk, all the way up to nk. All right. So they go into a little animation here. Illustrates the following example. A family of 4, right, 2 parents and 2 kids, goes on a hiking trip. The trail is narrow and they must walk single file. How many ways can they walk with a parent in the front and a parent in the rear? So again, we're trying to make a sequence, just like in the product rule in the first section, in section 10.1, but we're making a sequence where one choice depends on previous choices, right? Like your choice of the second trophy winner depends on the first trophy winner, right? If you've already chosen a first trophy winner, you can't choose that person again to win second. It's the same kind of thing, same kind of principle here. So again, the desired sequence, is parent, child, child, parent. Parent in the front, parent in the back. So how many choices do you have for the first position? So in the first position with a parent, right, you have the choice of mom and or dad, right? So two choices for the first position. You see that 2 in the first part of the product. Then times, you're making a sequence. So usually in the in the forming of sequences like this, or quadruples or triples or whatever, it's a product. Like in section 10.1. Then you have a choice of child. Now there are 2 children, the sister, the brother. Right, so times 2 again. And then once they're determined, though, right, if you've put mom and the brother in front, for instance, well, then the other 2 are predetermined. If you put mom and the brother, then it has to be sister and the father, or the other parent, because you want this particular kind of sequence. You want parent, child, child, parent. So there's only one choice for the next kid, and then one choice for the parent in the back if those previous choices have already been made. And then 2 times 2 times 1 times 1 is 4 choices. So there would be 4 possible ways they could order themselves to walk through this narrow trail. All right. Another example. Suppose that there are 3 employees in a startup company. They rent an office, right? They rent an office space with 8 offices, anticipating growth. The office space comes with 4 desks. Each person can select an office and a desk. The selection is done in the order that the participants join the company, with the founder going first. So how many ways are there for the selection to be done? So, each person is selecting an office, right, then selecting a desk. So if person 1, the founder, selects an office, they have 8 choices of office, right, times, and then they select a desk, they have 4 choices of desk. So 8 times 4. Times, and then, again, you're creating a sequence of like office, desk, office, desk, office, desk, right, for the 3 people. And then you see that see a 7 times 3 here, because like once the first person chooses an office and a desk, then there are only 7 offices and 3 desks left for the next person. So they have the 7 times 3 choices. Then times, and then the third person, right? Once the 2 offices are chosen and 2 desks are chosen, then you only have 6 and 2. And putting that whole product together, there'd be 8,064 different numbers of possible selections. So again, hopefully these examples make some kind of sense. Alright, so let's do one on our own, and this looks like the end of it here before the exercises. So in the following question, a club with 10 students elects a president, vice president, secretary, and treasurer. No student can hold more than one position. Alright. So how many ways are there to select the class officers? So I'm going to pull up a piece of paper here. Hopefully you can see it off to the side. So in this first part, right, for number 1, we're trying to create this kind of a sequence, right? The desired sequence is president, vice president, secretary, treasurer. That's the desired sequence. And then you just go through and say, how many choices do I have for each? So the number of these sequences that I could form, right? The number of possible choices I can form. My choice of president. There are 10 students in this club, so I have 10 choices for that first slot. Times. Now for the vice president, once I've chosen a president and it said no student can hold more than one position, so I can't have the same person be president and vice president. Then there'd only be 9 choices left, for the vice president, and then times, and then continuing on with this sequence. Once the president and vice president are chosen, then there'd be only 8 choices left for the secretary. Times, and then once all 3 of them are chosen, there would only be 7 choices left for the treasurer. All right, and then let's see here. 8 times 7 is 56. times 9 would be 450 plus 54, 494 with a 0. Alright, and I'll really verify that I did this right. I'll pull the calculator up here. 10 times 9 times 8 times 7. Right, yeah, so I was way off. All right. So 5,040, see. Oh, yeah, 450 plus 54 is not 494, it's 504. So yeah, that's where I went wrong. So yeah, that's 504 with a 0 because you times 10. So there are 5,040 different sequences I could make of president, vice president, secretary, treasurer. So that's what I'll enter here. 5040. Check it. It is correct. All right. Now, number 2. Right now, suppose that there are 5 girls and 5 boys in the club. How many ways are there to select the officers if the president is a girl? All right, so number 2, still doing the same sequence, but now the president must be a girl. And there are 5 girls and 5 boys. So again, the number of sequences here, president must be a girl. I only have 5 choices then to fill in that slot. Times, and then once the president is chosen, the other people can be a boy or a girl. Doesn't matter. Right? They just said the president has to be a girl, and that was it. Now the president's already selected, so there's only 9 people left to choose from for the vice president, times only 8 for the secretary slot, times, and then 7. So really I just cut this in half, right, because half of 10 is 5. I just cut this in half here. So 2,520. Right. So that'd be 2,520 different ways to select the offices if you had to choose one of the 5 girls to be president. Okay, wonderful there. Then finally, again, suppose that there are 5 girls and 5 boys in the club. How many ways are there to elect these officers if the president is a girl and the vice president, must be a boy? So now president's girl, vice president has to be a boy. So again, this selection of the filling out the slots in this sequence. Choose a girl president. There are 5 choices. Choose a boy vice president. Now I've only chosen a girl, so there's still 5 boys left to be chosen to be vice president. So 5 times 5. And then the other 2, the secretary and the treasurer, can be either boy or girl. So I've already chosen 2, meaning there are 8 people left. Right, so there are 8 choices left for secretary, and then after that there are only 7 people left to choose from for treasurer. All right. And so this one, let's see, 5 times, this is 2, pull a 2 off of that, 10, another 2 at 10, 1,400. Yeah, I think that's 1,400. So there are 1,400 ways to select the officers if that's the case. All right. Okay, wonderful. All right, so hopefully this generalized product rule makes some sense. All right, it's just you're filling out slots in a sequence, kind of like in the original product rule. Only now elements can't be repeated. And if you make one choice, choices later in the sequence depend on choices previously in the sequence. And then you have your additional exercises. Again, some of these are assigned, some are not. I think all of them might be assigned. There aren't that many here. But if they aren't, I would still recommend doing all of them, trying all of them, just to make sure you're getting more exposure, getting better at the material. And of course, you can look at the solutions, check how you're doing, right? But please, try to work them out first. Try to figure out what's going on first before you look at the solutions. Because if you're just copying down solutions without working at it, you're not going to learn anything. And of course, if you have any questions, send me a message and I'll get back to you as soon as I can. Try to help you out. And thank you very much for watching.